All right, we are going to start a brand new chapter titled The Building Blocks of Matter. And so we are going to dive into atoms again, talk about the atom from a philosophical idea to a scientific theory. In the second section, we'll get into the structure of an atom, and some of them might feel like review. And then we will finish chapter 3 with some math conversions, converting atoms to moles and moles to grams and all of that fun stuff right there. So 3.1 is going to focus on the atom from a philosophical idea to scientific theory. So I'm going to describe 3 laws that show or talk about how matter behaves in chemical reactions, discuss compounds and how they contain atoms in whole number ratios, and then talk a little bit about Dalton's atomic theory and how atoms, can be subdivided into smaller particles. So the first section, or the first law I want to talk about is the law of conservation of mass. So there are 3 basic laws that describe how matter behaves when they undergo chemical reactions. And the first one is the law of conservation of mass, which just states that mass is neither created nor destroyed during ordinary chemical reactions or physical changes. So what that says is if I have 32 grams of sulfur and I combine it with 56 grams of iron, and I add these 2 numbers up on this side, so 32 plus 56 is 88. Well, whatever happens during this chemical reaction, in this case I'm adding heat, we did this with our mixture lab, it's going to turn into a new compound, iron sulfide, or iron 2 sulfide, I think maybe. But it's a new compound with maybe new sets of properties, but whatever is formed, I'm going to have 88 grams of products. So when I took this test tube and I applied heat in the back lab, we noticed that gases and fumes were given off. If I could capture that, just know that I would have 88 grams of products. So whenever you see a chemical reaction occur and it looks like the products is less than what you started with, there's a good chance that maybe some of it escaped as like a gas. Okay, but just know that if you could trap it, you would have the same mass of products as you would when you started, with your reactants. Okay, the law of definite proportions is the second law I want to discuss. It states chemical compounds contain the same elements in exactly the same proportions by mass, regardless of the size of the sample or source of the compound. So that's, if I have table salt, okay, table salt is NaCl, and I were to, take a look at the size of these ions and say, okay, 60.66% is chlorine and 39.34% is sodium. I take a gram of sodium chloride, the percentages are going to be the same if I have like 1,000 grams of sodium chloride. Okay, so yeah, it's just stating that, regardless of where or how a pure chemical compound is prepared, it's composed of a fixed proportion of elements, no matter what. I think we had a question way back, I think maybe it was chapter 1, about sucrose from a sugar beet and sucrose from I think it said plant. How do they differ? How are they similar? Well, they're the same compound. Okay, they're just made from different plants, but the chemical composition of sucrose in those 2 plants should be the same. Oh, it's right here. Gosh, I'm dumb. It's right here on the bottom. Sorry. So sucrose from sugar beets and sugar canes and sugar maples are all C12H22O11. Okay, there. Wow. So it's kind of like a brownie recipe. Okay. You read the brownie recipe. If the ingredients are mixed according to the recipe, the brownies should turn out the same every time, no matter who makes them. Now we know that's not always the case because some people are just really bad, in the kitchen. But theoretically, in theory, no. If you follow the recipe and do exactly what it says, your brownies should come out the way that they should. Okay, the third law is the law of multiple proportions. Okay, so 2 elements combine to form 2 or more compounds. the mass of one element that combines with the given mass of the other is the ratio of the small whole numbers. So let's just take a look at this table. This table is very similar to the one in your book, sort of. Your book deals with, I think, carbon dioxide, and this is nitrogen and oxygen. So here I have nitrogen monoxide, one nitrogen and one nitrogen and one oxygen. And so it just talks about the description of nitrogen monoxide, colorless gas that reacts readily with oxygen. So one of each. The formula is NO. The mass of oxygen on the periodic table is 15.99, so they round to 16. The mass of nitrogen is 14.01. Okay, so if I take 16 grams of oxygen divided by the mass of nitrogen, 14.01, I get this ratio basically of 1.14 grams of oxygen to 1 grams of nitrogen. Okay, so 1 to 1 there. Now, what happens when I have nitrogen dioxide? So nitrogen with 2 oxygens. So we have a different compound here, in this case, poisonous brown gas and smog. Here's the formula, NO2. Notice my mass of oxygen, what happened to it? It doubled. Okay, I got 2 oxygen atoms here, so the mass is going to be doubled. But my mass of nitrogen stays the same because I just have 1. So now let's take a look at the mass to mass proportion here. 32 grams of oxygen divided by 14.01, I get 2.28 grams of oxygen to 1 gram of nitrogen. Now, how would you compare these two numbers? Okay, so the nitrogen stays the same, but your oxygen, we doubled it, right? We added an oxygen, NO versus NO2, so that means our mass is going to be doubled as well. So that's all that this is saying. So here I have NO, the 14 to 16 ratio, there's that 1.14. Here's my NO2, the 2.29 they rounded, so there must be a third digit and they rounded up, sig figs, right? What happens if I go N2O, right? So now my nitrogen is 28 to 16. Look at that ratio. Okay, that makes sense. N2O2. So it's just looking at the proportions of each atom, and you just notice that that these are whole numbers when you double it. I don't have half an oxygen, so yeah. Okay, I'm going to move on to John Dalton. So John Dalton was a school teacher back in the early 1800s, and he proposed basically an explanation that it encompassed all of these 3 laws that describe what happened in a chemical reaction. And so we kind of call it Dalton's atomic theory. So these are the 5 statements. Number 1, all matter is composed of extremely small particles called atoms. And atoms means undivisible. 2, atoms of an element are identical in size, mass, and other properties. 3, atoms cannot be subdivided, created, or destroyed. That kind of ties in the law of conservation of mass. Statement 4 focuses on the law of definite as well as multiple proportions. Atoms of different elements combine in simple whole number ratios to form chemical compounds. You can't have half an oxygen atom, okay? They're whole numbers. And then 5, in chemical reactions, atoms are combined, separated, or rearranged, focusing in on the law of conservation of mass there. Okay, now of John Dalton's atomic theory, some of these statements no longer hold true anymore. Okay, Dalton, I don't know how to say this, but not all of his statements, are proven to be correct. We know today that atoms are divisible into even smaller particles, right? We can take atoms and subdivide it, break it down into its subatomic particles, and know that those subatomic particles can be further subdivided. But when they can't be created or destroyed, they still maintain the law of conservation of mass. So that statement right there really no longer holds true. The ones that really remain unchanged from Dalton's atomic theory, so his theory doesn't change, it's just modified, okay? So the ones that really remain unchanged is that all matter is composed of atoms. Okay, and the second one that atoms of any one element differ in properties from atoms of another element. Okay, so these two basically remain unchanged. I really don't know why I should have taken that out. Of another element, remain unchanged, like take that out. Okay, so that is section 1 in summary. We just went through, I don't know, the 3 laws that describe what happens in a chemical reaction, the 5 main points of Dalton's atomic theory, what chemical laws can be explained by Dalton's theory. So your assignment is to do the 3.1 book worksheet, which is due tomorrow. Tomorrow we'll, I think we'll move on with section 3.2, structure of an atom.